This is the first of 6 lessons on descriptive statistics. We begin by defining how data and variability form the basis of statistics. In this lesson, we will answer 4 key questions. What are data? How are data used in statistics? How does the notion of variables and variability fit into statistics? What are the different types of variables and how are they measured and reported? The Webster's Dictionary definition of statistics is the science of reasoning from data. So what is data? Is it always numerical?
The Webster's Dictionary definition of data is: data are factual information used as the basis for reasoning, discussion, or calculation.
Data is factual information that describes individuals, which are called the observational unit in statistics. In education, for example, these individuals being observed may be students, teachers, classrooms, schools, or textbooks. Individuals, for example students, vary in many ways. If they were all the same, there would be no need to study statistics. So variability is a main reason to study statistics. Descriptive statistics scientifically reports facts about individuals. We define a variable to be a characteristic of an individual. Examples of student variables are gender, ethnicity, grade on a reading test, age, birthday. Variables can be divided into 2 main types, categorical and quantitative. Categorical variables measure qualitative features of the individual. They record the group or category to which the observational unit belongs. Quantitative variables are numerical measures of an observational unit for which it makes sense to do arithmetic operations, such as adding or averaging. Here are some student variables. Pause the video while you take time to identify the variables: ethnicity, race, school attended, math EOG scale score, reading achievement level, distance home is from school, grade on science test, as a categorical or a quantitative measure of a student as the observational unit. When you have your answers ready, restart the video and the answers are on the next slide. Now pause the video. Now check your answers. Ethnicity, race is categorical. School attended is categorical. Math EOG scale score is quantitative. Reading achievement level, categorical. Distance home is from school, quantitative. What did you say for a grade on a science test? What kind of grade are we talking about? Sometimes we need to know what kind of values are being assigned to a variable before we can tell what type it is. Letter grades, A, B, C, D, F, or level grades, 1, 2, 3, 4, are categories. They cannot be averaged, but 0 to 100 grades are numerical and can be averaged. So the grade would be quantitative. Scale scores are also quantitative. There are 2 types of categorical measurements, nominal or ordinal, and 2 types of quantitative variables, interval or ratio. Nominal categorical variables are names that have no order or rank. Examples are gender or ethnicity, race. We may alphabetize these variables when we report them, but there is no numerical reason for females to come before males. Ordinal categorical variables do have a natural order. Examples are grade level in school, such as freshman, sophomore, junior, senior. Percentiles or Likert scale responses, such as strongly agree, disagree, strongly disagree. Interval quantitative variables have a numerical order with equal intervals between them, but no natural zero that represents the absence of the variable. Temperature scales help us understand this type of variable. Temperature scales are interval data where 75 degrees is warmer than 70 degrees, and a 5-degree difference has some physical meaning. Note that the designation of a temperature as 0 degrees is arbitrary and does not mean the absence of temperature, so that it does not make sense to say that 100 degrees is twice as hot as 50 degrees. A good educational example of an interval variable is a scale score. Ratio quantitative variables have a numerical order with equal intervals between them and a natural zero that represents the absence of the variable. Examples are height, age, length, and distance. Each of the 4 types of variables can be used to describe an observational unit, but it is important to select an appropriate reporting method. Nominal data is best reported as counts or percentages. For example, there are 15 female students. 30% of the students are Asian. Ordinal data is reported using counts, percentages, or logical comparisons, such as less than, greater than, or equal to. For example, 300 students are in 9th grade. 30% of the teachers strongly agree with the statement. Sarah's score placed her at a higher percentile than Amy. Appropriate reporting for interval data includes counts, percentages, logical comparisons. Addition or subtraction can be used, but no averages. Examples are 50 students had a scale score of 156. 45% of the class scored above 156. Jean's score is the same as Tom's score. The difference between Jean's score and Tom's score was 2 scale score points. Ratio data has the most reporting options available. Counts, percentages, logical comparisons, addition, subtraction, and averages are all appropriate. Examples are 3 students are 14 years old. 10% of the students are 15 years old. Juan and Kevin are the same distance from school. Anne travels a total distance of 8 4/10 miles each day. The average height of students in my class is 56 2/10 inches. Despite the stated concerns about averaging ordinal or interval data, averages are found and reported for Likert scale data and for standard scores. This is done with the assumption that the space between any 2 scores is the same. Exercise caution in interpreting these statistics.
Can you now answer the 4 lesson questions? The questions are: what are data? How are data used in statistics? How does the notion of variables and variability fit into statistics? What are the different types of variables and how are they measured and reported? If you feel uncomfortable with any of these questions, you may want to review parts of this lesson again. You can do that by using the menu on the left. This is the end of Lesson 1. Lesson 2 is Displaying the Data. It explains several ways to make graphical, pictorial displays of your data that will help you better visualize the variability.